Hi there, this is A-Level Physics, Conservation of Energy example questions. So the objective is simply to practice and solve conservation of energy problems. Here's question 1. If you want to have a go at this, just pause the video and then I'll take you through it. So question 1, a cricket ball of mass 0.2 kilograms is thrown vertically upwards with a velocity of 20 meters per second. When it returns to Earth, it has a velocity of 15 meters per second. Calculate the thermal energy loss due to air resistance. So this is quite simply going to be the loss of kinetic energy. So we can calculate the kinetic energy for the 20 meters per second. So it's just a half times the mass times 0.2 times 20 squared. And if you put that in your calculator, you'll get 40 joules of energy. And then we just need to compare that to the kinetic energy at 15 meters per second. So that's just going to be a half times the mass again, multiplied by 15 squared. And that's 22.5 joules. So the difference between them will be the loss due to air resistance. So it's just 40 subtract the 22.5, which means there's 17.5 joules of energy has been lost due to air resistance. Okay, let's have a look what's next. A bit more complicated, but if you want to try this one, just pause and then I'll take you through it. So question 2, a mass of 4 kilograms slides down this ramp. The speed at the bottom of the ramp is 4 meters per second. Calculate the average frictional force acting on the mass. So what we need to do is we need to compare the gravitational potential energy that this mass has initially, and then subtract it from the kinetic energy at the bottom. And then the loss of energy, the difference, is the energy loss due to the frictional force that's acting on the mass. So to calculate the GPE, I'm going to need the height. And to calculate the frictional force, we're going to need the hypotenuse as well. So we can calculate both of those first. Starting with the height. So let's label it up. So this is opposite the angle, this is adjacent. So it's just going to be tan of the angle, tan 30, equals opposite over adjacent. So opposite, what we're looking for, divided by 3. So the opposite is simply 3 times tan 30. And that gives us root 3 or 1.73 meters. So let's just label that up. So 1.73 meters, that'll be fine. Then we need to find the hypotenuse. So to do that, let's label it up. So that's the hypotenuse, and this is the adjacent. So it's cos 30 equals A over H. So 3 meters divided by whatever the hypotenuse is. So the hypotenuse is 3 divided by cosine 30. And that gives us 3.46 meters. So let's calculate the GPE first. So the GPE is equal to mgh, so that's 4 times the mass. Sorry, 4 is the mass, m times g, 9.81. Multiplied by the height, which we figured out to be 1.73 meters. So that gives us 67.89 joules. And then we can calculate the kinetic energy of the mass at the bottom. So that'll be a half times the mass times 4 times speed squared, and 4 squared is 16. So half of 4 is 2, 2 times 16 gives us 32 joules. So the energy that's missing will have been converted into thermal energy due to the frictional force that's acting on the mass. So we need to do the 67.89 and subtract 32, and that gives us 35.89 joules. So that's our work done by the frictional force, or against the frictional force. So work done is force times distance. So we can do the work done, which is 35.89, is equal to the force, which is what we're looking for, multiplied by the distance, and the distance is the 3.46 meters. So force is the 35.89 divided by 3.46, and that gives us a force of 10.4 newtons. Hopefully that went okay. Let's have a look at the next one. So if you want to have a go at this one, just pause. So question 3. A ball of mass 0.2 kilograms is projected horizontally from the top of a wall 5 meters above ground level at a speed of 6.5 meters per second. Just before it hits the ground, it has a speed of 10 meters per second. Calculate how much energy has been dissipated into the surroundings. So this one's a little bit tricky. We need to do the total energy of the ball as it's projected from the top of the wall. So it's going to have two types of energy. It's got the kinetic energy due to its speed, and it's got its gravitational potential energy due to its height above the ground. We then need to compare that to the energy that it has just before it hits the ground, which will just be solely its kinetic energy with its speed of 10 meters per second. The difference between the 5 meters above the ground and the ground level will be the energy that's been dissipated to the surroundings. So let's get the MGH initially. So the mass is 0.2 times the gravitational field strength, 9.81, multiplied by the height, which is 5 meters. So that gives us 9.81 joules. Then we need its kinetic energy. So it's 0.5 times the mass, 0.2, times the speed squared, which is 6.5 squared. And that gives us 4.225 joules of energy. So that's our total energy at the top. So if we add those together, that gives us 14.035, or 14 joules. Then we just need to calculate the energy at the bottom and then do a comparison. So the energy at the bottom is just the kinetic energy. So that'll just be half mv squared, so 0.5, times the mass, which is 0.2, times 10 squared, which is 100. So that's the kinetic energy. So half of 0.2 is 0.1. 0.1 times 100 gives us 10 joules of energy. So the 14 joules is the total before, and the 10 joules is the total after, and the difference between them is the energy that's been dissipated to the surroundings. So 14 take away 10 gives us 4 joules. Let's move on, let's try another. It's question 4. If you want to have a go, just pause. A sledge of 0.2 times 10 to the 3 kilograms starts from rest at the top of a hill and slides down the hill without any driving force being applied. By the time it has fallen through a vertical height of 50 meters, it has acquired a speed of 20 meters per second. Calculate the energy dissipated due to the frictional forces. It's quite simple on this. We just need to calculate the loss of gravitational potential energy and then compare it to the kinetic energy. The difference between will be the loss. So the GPE is MGH, so we need to do the mass, 0.2 times 10 to the 3 multiplied by 9.81 times the vertical height of 50 meters. That gives us a GPE of 98,100 joules. And then we just need the kinetic energy at the bottom. So kinetic energy is going to be a half mv squared. So it's a half times the mass, 0.2 times 10 to the 3, multiplied by 20 squared, which is 400. So that gives us 40,000 joules of kinetic energy. So the difference between them will be the energy that is dissipated due to the frictional forces. So you simply just need to do 98,100 subtract 40,000, and that gives us 58,100 joules. Quite straightforward for the others. Let's move on to the last one. So let you have a go at this one first. Just pause the video. So question 5, a 3 kilogram ball is thrown vertically into the air with a velocity of 7.5 meters per second. By the time it is at a height h meters above the starting point, it has a velocity of 2.5 meters per second and has done 3.5 joules of work against air resistance. Calculate the height. So it can be quite tricky. So initially the ball has kinetic energy. Of half mv squared. So that's the initial. That has got to be equal to then the gain in potential energy, mgh, that the ball has when it's at height h, plus the kinetic energy that's still remaining, plus the 3.5 joules of energy that's been converted due to the air resistance. So the initial kinetic energy is 0.5 times 3 times 7.5 squared. So initially, if you do 0.5 times 3 times 7.5 squared, you get 84.375 joules equals. Then we can do the kinetic energy afterwards. So that will be 0.5 times the mass of 3 multiplied by the speed squared, 2.5 squared. That gives us a kinetic energy at height h of 9.375. And then we can simply add the 3.5. And then we've obviously still got the mgh. So we can tidy this up to get mgh by doing the 84.375 and subtracting the two quantities on the right hand side. So if we just do 84.375, subtract 9.375, and then subtract the 3.5, that remaining energy, the remaining 71.5 joules, is equal to the gravitational potential energy. So I can write 71.5 is equal to mgh. So we know m is 3 kilograms and we know g is obviously 9.81. So we can do 71.5 divided by mg. So 3 times 9.81. And that gives us 2.43 meters. Hopefully that's helped a little. I'll speak to you soon. Thank you.